Okay, here's another problem for conservation of energy principles, because we're talking about here, and gravity's a conservative force. Here we go to pendulum. Pendulum is when you have something on a string and it kind of, you pick it up and then you release it and it kind of like oscillates back and forth through as gravity pulls it and so on and so forth. So they say that you're going to pick this up at some unknown height. So we've got some height here, h. We don't know what that height is. That's the goal, to find out what that height is. We release this pendulum at some height, and the pendulum swings, and right here at the bottom, where the string is here, you find the pendulum is moving with a velocity, I believe, of 1.9 meters per second. And that's it. That's all the information that we're given. Let me just check that, because I'm doing this one from the book. 1.9 meters per second. And so our mission is to find out what was the height from which the bob, which they call this thing here, the bob on the pendulum was released. Well, conservation of energy, right? Right at this point here, let's call this position 1. Let's call this position number 2. All right, so at position number 1, what's my total energy? Well, I've got potential energy at position 1 is mgh. I got kinetic energy at position 1, which is 0. Why is it 0? Because it's still. I'm holding it here in that position. Now, on position 2, we got potential energy, which is 0. Why? Because now I'm at what we're calling the ground level of the pendulum. So for potential energy, we're just looking from here, how much is it going to be raised up from the 0 level, which we arbitrarily assume in this case is just where it's staying on the bottom. But it does have kinetic energy, and this is for 2, which is 1/2 m v final, over there, v at 2, squared. Now the total energy here, energy total 1, and this is energy total 2, has to be equal, because the total energy is constant, so it stays the same. So what's the total energy here? Well, it's the mass, g, times the height, plus 0, because there's no kinetic energy, because the velocity is 0 when you're holding it still. That has to be equal to the total energy at the bottom over here at position 2, which is going to be 0 for potential energy, but everything now is kinetic energy. 1/2 m v squared. Now something interesting happens. You don't need to know the mass, because they kind of cancel out of this equation. And you'll find that oftentimes when you're talking about conservation of energy, because mass is something that is involved with both the potential and the kinetic energies, that when you equate total energies in an equation form, the masses will all cancel out and they'll be irrelevant. So we don't really have to be considered or worry about mass. So our equation breaks down to this. GH is equal to 1/2 V, and we know what V is. We're told it's 1.9. So 1.9 squared. So our height then is going to be 1/2 of 1.9 squared, and this g is 9.8. Whole thing divided by 9.8. And if you do that, you will find that to be 0.18. Oh, I'm sorry about that. 0.18 meters. That 0.18 meters is how high the pendulum bob was when it was released. If you're giving this information, you can find the height. You don't even need to know the mass. Okay, so that was just an extra problem there, where we did total energy being constant, conservation of energy, which the energy that you start with is the energy that you finish with when you're talking about gravity, because there's no lossy forces like friction present. So I hope that helped. And the next video, I'm going to just say little bit about power, and we're going to be done with chapter 5.